Now let's talk about the concentration of our solution. There are different ways to represent the concentration of a solution. However, regardless how it is expressed, it is always refers to the amount of solute present in a specified amount of solution. Again, it is always the amount of solute in certain amount of solution. It will never be the amount of solute in certain amount of solvent. Never. Later on, you will understand what I mean here. Overall, there are two different ways to represent the concentration of a solution. One is percent concentration, the other is called molarity. Percent concentration is our today's topic. Molarity will be in the next episode. Percent concentration, there are actually three different ways of representing percent concentration. Percent by mass, percent by volume, and percent by mass over volume. Percent by mass equals the mass of solute divided by the mass of solution multiplied by 100 to convert it into a percentage. Again, at the bottom is the mass of solution, not the mass of solvent. Mass of solution means the sum of the mass of solute plus the mass of solvent. Example, what is the percent by mass? By dissolving 6.6 grams of glucose in 93.4 grams of water. So the mass of solute, 6.6 grams, divided by the mass of solution is not 93.4. 93.4 is the mass of solvent only. You need to know the mass of solution, which is the solute plus solvent. So 6.6 plus 93.4. Then convert it to a percentage. You're going to get 6.6%. Make sense? Now percent by volume equals the volume of the solute divided by the volume of the solution. Again, at the bottom is the volume of the solution multiplied by 100. Calculate the volume percent of solute in 25 mils of methyl alcohol. Methyl alcohol is the solute. Enough water to give for 75 mils of solution. For 75 mil is the volume of the solution. Calculate the volume percent. Okay, let's use that to do the calculation. You can pause the video, try to do it by yourself, and then come back to look at the answer key. All right, the answer is 5.26%. Did you get it right? I hope you did it right. If you get a 5%, I hope you know where your mistake is. Okay, let's do it together. Percent by volume equals the volume of solute, which is 25.0 mil in this case, divided by the volume of the solution. The volume of the solution is 475 mil. Why don't we add 475 and 25 together? Because 475 is the volume of the solution. That's what it is. You do not need to add anything to it. Multiplied by 100, you're going to get 5.26%, 3 sig figs. Now the third kind of percent concentration, mass over volume percent. Mass volume percent equals the mass of the solute divided by the volume of the solution. The mass needs to be in grams, volume needs to be in milliliter. Again, it is the volume of the solution. Then multiply it by 100 to convert it to a percentage. A solution is prepared by dissolving 10 grams of glucose to give 325 mils of solution. What is the mass volume percent? All right, again, you can pause the video and do it by yourself, and then come back to check the answer. This is the answer. I hope you got it right. It is very straightforward. You just use 10.0 grams divided by 325 mil. 325 mil is the volume of the solution again. Yep, then convert it to a percentage. You're going to get 3.08. Again, 3 significant figures. All right. Concentrations, all concentration are conversion factors. Let's focus on the percent by mass. Okay, if a concentration given is 15% of a sodium chloride solution, that means in every 100 grams of solution, there are 15 grams of solute. That's a conversion factor. It is a ratio of two different units. On the top is grams of solute, which is sodium chloride. At the bottom is grams of solution. It is a ratio of two different units. It is a conversion factor. For any conversion factor, there are always two ways to write it. You can put the numbers of the solution on the top, numbers for the solute at the bottom, or in a different way, depending on what information is given, what information is wanted. So when you see a conversion factor, you know when to use it. You need a conversion factor to set up a dimensional analysis question. Okay, let's do it together. How many grams of sugar are there in 150.0 grams of 6% sugar solution? All right, let's identify the given unit, identify the wanted unit, and set up the conversion factor. The given unit, we know grams of solution. We know 150.0 grams of solution. Well, we know that as well. We know the concentration as well. Well, remember, concentration is a conversion factor. You will never start your setup. You will never start your dimensional analysis setup by a conversion factor. So that's your given unit, and your wanted unit is grams of sugar. Once you know the given unit, wanted unit, and if they're different, you know you need a conversion factor. And you need to set up your conversion factor in such a way that the unit of given information is at the bottom. The unit with wanted information is on the top. We have done this hundreds of times, maybe. All right, that's your setup. Now let's plug the numbers in. We know we have 150.0 grams of solution. What is this? The ratio of sugar, which is solute, and the amount of solution. Well, that's concentration. 6% means you have 6.00 grams of sugar in every 100 grams of solution. Make sense to you? Now, if you do the math, you plug this number into your calculator, multiply it by all the numbers on the top, divided by all the numbers at the bottom, you're going to get 9.00 grams of sugar. 3 significant figures. Another practice. How many grams of sugar are needed to be added to 235 grams of water in order to prepare a 6% by mass sugar solution. All right, let's follow our procedure, identify the given unit, identify the wanted unit, and set up the conversion factor. The given unit is grams. The given unit is grams of water. We know how many grams of water is given. The wanted unit is grams of sugar. Now, if the two units are different, you need a conversion factor. The conversion factor needs to be set up in such a way that the unit with given information needs to be at the bottom. The unit with wanted information needs to be on the top. Yeah, that's pretty much is our setup. So now let's plug the numbers in. 235 grams of water. And what is this now? This is a ratio of solute and solvent. This is not a concentration. Concentration is the ratio, like if you see here in the table, concentration is the ratio of solute and solution, not the solute of water. So let's look at this concentration again. So this concentration tells us there are 6 grams of sugar in 100 grams of solution. Clearly, in that solution, 100 grams, it is the sum of sugar and water together. Now let me ask you a question. If the concentration is 6%, then in that 100 grams of solution, how many grams of them is sugar? 6 grams. Does that make sense to you? If the sugar is 6 grams, water will be 100 minus 6 grams. For every 6 grams of sugar in the solution, there are 100 minus 6 grams of water. Does that make sense to you? All right, now we got a ratio between sugar, grams of sugar, and grams of water. For every 6 grams of sugar, you will have 100 minus 6 grams of water, which is 94. Okay, which should be, this is actually 94.00 grams of water. So now you do the calculation. 235.0 times by 6.00 and divided by 94.00. If you do the calculation, it is going to be 15.0 grams of sugar. I hope that makes sense to you. See you next time.